domain name system. It helps you resolve the names of the sites with the IP addresses they have attached. And first, from the beginning, we'll speak about two contexts, which are public DNS resolution and private DNS resolution. Knowing that we have these two spaces from the networking standpoint, we have the public one and the private one. The DNS serves these two contexts. And the simple example is we have an IP address. This is the IPv4 version. Then we'll have also, of course, IPv6 today, which need to be solved, to resolve it. And we have www.example.com, which will point to this IP address. And we have different steps in order to understand how it works globally. We have several DNS servers in this workflow, and all of them will help have the final resolution, right? And the first thing happen is the computer tries to find this address, right? And it is, first of all, sent to recursive resolver, which is the first level who will understand how to segment the resolutions from the domain name perspective. And the first level afterwards is the root server, which helps resolving the root domain. Then we have the TLD, the top level domain, and then we have the real authoritative name server, which will solve your precise domain. So the root domain is typically the .com domain, right? And then we have the top level domain, which is example.com. And then you may have a specific thing like www or other subdomain, and this will be resolved by the authoritative name server that has this record or this zone in particular. Okay. So we have several terms to recall, and one of them is the IP address. You already understand what is it, and the FQDN, which is the full qualified domain name. It's the address that you use in order to go to a server site, right? The registrar is an important term because this is where you have your domain registered, and from there you need to have the configuration to where to point to solve the DNS request, and this is at the registrar level. I mean, you are in the public domain, and you need to specify which name servers you use. And if you don't specify anything, it will propose your default set of name servers. So you can already solve this thing. No, you don't have a particular reason to change that, but you can do that, and you can have your own name servers solving these things, right? Then we have the term of the zone, which is typically a subdomain, for example. And in the zone, you have records, and you have different types of records. The most significant one is the A record, which binds an IPv4 IP to a name, right? And the equivalent for IPv6 is 488, so AAA record. And maybe the third one important is to have a CNAME or alias, which lets you point from an address, name and name address, to another name address, right? Just an alias. Then you have records like PTR. PTR is a reverse record, which lets you point from the IP to the name in the opposite sense. The SOA, you'll see this record right next because it's the essential root rules for having a zone configured actually. And then you have other different type of records and so on. And you have here on the right side an example of a query, which is on the Windows server. You have an NSLOOKUP, which is the usual command to use for that. And you have www.google.com, which solves on IPv6 and on IPv4 on down. Okay, so there are other things around on DNS, specifically the fact that you have many levels of resolution needed. If you see that again in the first slide, you see here that you have several ping pongs to be done at the initial step, and if at each request the client would do that, we would never have the performance for today. This is the reason why you have different level of cache actually, and you need to understand this cache on the road in order to see how is the propagation of these rules, and this takes time. This is notably related to the TTL configuration, which is time to live, and lets you specify a certain duration of a record, for example. Okay, this is important for the next step to understand, especially the condition of the demo. Okay, so where's Azure DNS in this? So Azure DNS is nothing more than a DNS hosting service, which is stored in Azure. And typically, it's essentially what other services do for solving DNS, so other name servers do, except that there are several features that are really interesting in Azure, and we will focus on that later. This is Azure DNS General Service, I mean the public one, right? And the first obvious things that come when we speak about Azure services is that this kind of service is managed in Azure. So you don't have to install a name server, you don't have to patch it and so on. It's a PaaS service. And that means a lot of return of I would say ROI for your enterprise would may be good. Then you also can manage all these things like other Azure resources. I mean, you can have RBAC, so the security level control, authorization, authentication, and you have the logging, and you have things like resource locking, like other Azure resources. And Azure DNS Public DNS supports all types of records that we saw before. This is the glimpse of the page in the Azure portal, which lets you edit and configure the DNS records. And you have here actually the list of the name servers that you need to configure in your registrar in order to delegate this resolution to Azure DNS. This is where you will specify the configuration, so in the registrar configuration, in order to point to Azure DNS in that case. And this workflow simply repeats what I've exemplified before, except that here you have for the Azure for the top-level domain and for the real authoritative servers coming afterwards, you have Azure DNS zones, and they will be used instead of others name servers, right? Now, Azure DNS for private domains, so Azure or Azure Private DNS is the same thing, except that it is in a private domain, right? So you have for private IPs the resolution inside the company, and you use our own custom domain names to be mapped to the IPs, knowing that Azure already delivers automatically names for the VMs that we host in Azure, but we need to manage this kind of thing. We need to master, I don't know, the names of the VMs. And this is where Azure Private DNS come into place. So once again, the benefits, it's managed service. It have an SLA, of course, but one important point to remark that the service is in public preview today, so that it doesn't have an SLA, okay? And it lets you have these kind of general things, but in addition to that, it offers also some specific functionalities, like automatic host name record management and host name resolution between virtual networks. These two things, we'll explain them in more detail. Automatic hostname record management lets you add automatically to the zone a name for each VM that is hosted in a particular VNet, and you have the name of the resource which is the VM. It will be used as the name of the record set actually for the DNS. So if you call the VM, for example, my app-vm01, for example, and you'll have a zone called contoso.local. In that case, automatically when you create a VM and you will have already Azure Private DNS configured for that VNet, you'll have a new name for that VM, which will be my application-vm01 .contoso.local. This is very practical because you don't need to create lots of records and manage this. It's done automatically for you. Another thing is the hostname resolution between virtual networks. So as you'll see, there are things to understand for this resolution. Actually, there are two terms specific. You have first of all the term of the resolution, which means that you can resolve for the VNets that are allowed, resolve records within the zone. Not all the VNets are able to do that. Of course, that you have some VNets, and Azure doesn't know specifically which VNets you want to have this visibility to the DNS zone. So you will specify this capability by configuring the resolution of the Azure DNS private zone in the VNet. So this is the resolution. It's an association of this zone to a particular VNet. And the second one is the registration. And the registration is this feature that I've told you about just before, about creating automatically a record for each VM that is created or deleted or changed. Okay, there are other capabilities like reverse DNS lookup, but supported only within the virtual network scope and not for those that are attached by resolution. So there are several scenarios, which are some of them pretty obvious, but we'll move further afterwards to more complex ones. So first of all, the classical scenario, we want to have a resolution of the VMs that are in a particular virtual network, and we need to also have automatic registration feature. So in that case, we'll create a zone and we'll associate it with the virtual network as a registration. And then you will have automatically two records in the zone, which will be the VM1 for the first IP and the VM2 for the second IP. Of course, you can add your own records manually. Another scenario will be a same zone, but used across different VNets. And this is where the things come into play. They are more interesting. So let's imagine that we have this zone. Do I have a laser on that? You know, is it this one? Yeah. Okay. So we create a zone, okay, and then we attached it as registration to the first virtual network, and we attach it as a resolution to the second virtual network. So in this case, we'll see that there are plenty of resolutions possible. So for example, this VM will query for the VNet A VM1, and will have its response. You see, it's this one, and it works because of the fact that we have this resolution attached. So you don't see any connection physically, like VNet peering or any other connection between the two VNets. It's only made through DNS, through this configuration. Okay, the same thing for the second, and this is the PTR query. That is a reverse query. This works for the registration association, but it doesn't work for the resolution association. So, and then you have example for different records that that we have, automatically or manually. Another scenario is the split horizon, which is also pretty interesting and classical in companies, is that you may use the same domain outside and inside the company, but with scopes, with different scopes. That means for the public resolution, you have the public IP address exposed by this VM, but for the internal resolution, it will resolve to the private IP, okay? And you have actually two zones. You'll have a public zone record, and you have a private zone record. And you have different records registered there. Okay, now this is an example of how to manage an Azure DNS zone. This is the PowerShell command to create a zone, new Azure DNS zone. And this is how we attach, for example, a VNet or a collection of VNets as a registration. Also, you have the commandlet to how to add a record set. You specify different parameters, the zone name, the records you may add, and the time to live for that. Okay. The same thing, absolutely similar, but this time in Azure CLI. Okay. And we'll move now to our enterprise context. So we have, except the things that we create in Azure newly as new environments, we have existing legacy IT infrastructure, as in many big enterprises, right? And you have typically the hybrid connections put in place that may be either VPN connection or express route, which is the MPLS configuration. We have typically multiple applications in the cloud that will be deployed. Each application will take its own VNet. This is how we work, by the way. This is how we scale actually in the enterprise. I'm working in a banking company, so that means we have many applications and many structures. And this is the way we scale by adding each application. Each application will be added on its own VNet. And then we'll use this hub and spoke pattern in order to interconnect these applications with a central hub, and then through the express route bridge to the on-premises, right? And the question is how to solve now the DNS queries across different VNets and also across the hybrid bridge. So for example, for the clients coming from our enterprise, from our PCs, for example, how to solve the DNS queries going to these applications. This is the case, right? And what type of solution we imagine for that? This is a bit larger than the Azure DNS, if you want. The advantage of the session, if you want, and this was a hidden gem of the session, is that not only oriented on Azure DNS, but you also have examples of infrastructure that is put on scale in the enterprise, and this is how we work actually. And we have the local network, and you have a client VM, and you have the DNS local server here. And we have different applications. So you have the first one, the second one, you have an application. Then you have a central hub, okay? And you need now to have this interconnection. So these connections are VNet peerings, and this is how actually the applications are available, and the client connects to the applications in order to simply work with it, right? Now, this connectivity over VNet peering and the bridge is specifically for the traffic once the DNS name is resolved. For the DNS part, we have different zones that are configured, and we have one central zone, which is the hub zone. And we have also something that we specifically need for the hybrid connection. We have a forwarder set, a set of forwarder DNS servers, and this is actually a deployment of 2 or more virtual machines. And these machines will simply forward the queries to the central Azure DNS service, and depending on the other configurations around, the central DNS service will, click next. So all these queries will be forwarded to the corresponding zone, which will be an Azure Private DNS zone resource. And at that stage, the request will be solved. The point is that we really need this set of forwarders for these client VMs, because there's no way to specify for this client VM that the resolution for that is in Azure, right? Actually, everything starts from the DNS server, which is on-prem, and he will forward all the queries for the all set of domains and subdomains that are exposed in the Azure environments. They will forward these queries to the forwarder DNS servers. They are typically 2 minimum, and they are configured to point to Azure DNS service. How they are configured, there's a particular IP that you'll see later that is reserved for that in Azure. And I forgot the arrow here to animate, but no problem. So now this becomes much more concrete, and you understand how it was, because this is how we implemented the demo. Coming from the big scenario, we have simulated in Azure everything, so I don't have anything in my enterprise or on my PC. Everything is in Azure. But the point is that here I have what we have, the local VNet, and it simulates the local system, right? And also here is the hub, and I've only simulated one application, and we have one VNet corresponding to that. So we have hub and spoke configuration with one hub and one spoke today, okay? And this is the VNet peering between them. And here I have actually a VPN connection between the two VNets in order to once again simulate a hybrid connection, because if I put a peering, it wouldn't simulate like a real situation, right? The VNet is pretty similar, as you can make the VPN connection is pretty similar to what you would do if you have VNet VPN connection from your premises to Azure. It's the same type of connection here. We have 2 servers here. So the DNS servers, the forwarders, are simply bind servers. So bind is a DNS server on Linux, and the configuration is pretty simple. I'll show you a bit later the configuration. Now, what's more interesting is on the configuration of the DNS zones. We have 2 zones. One is app.dns2019.local, and the other one is hub.dns.2019.local. And these zones are associated with each of the VNets as registration, okay? Both of them are marked as registration on their corresponding VNets. In addition to that, there's one configuration in additional for this zone, which is app.dns2019.local. It is also associated to this VNet as resolution, okay? Now, when I have a query coming from here, from local client VM, it goes here. I configured the DNS servers on the VNet, okay? And actually everywhere I configured this on the VNet. And these IPs are nothing else than the IPs of these two machines. Okay? So this way, everybody here knows that when I'm speaking about DNS 2019.local, it will be solved via these two addresses. My query coming from here will go to these two forwarders, and these forwarders will forward, they don't do anything, then forward the service to this Azure DNS service, which is 168.63.129.16. This is a particular IP reserved by Microsoft for the Azure DNS service. Now, based on the configuration that is detected, the queries come from a particular VNet, right? And this VNet is where these DNS servers rely. Based on this, the DNS service in Azure is capable to say, yeah, you have two DNS zones that can be solved from this. The first is its own, and the second one is this one. So I can solve you these queries. If you ask me for app.dns or something around this, www.app.dns2019.local, I can solve this by querying the responsible zone for that. Okay? And if we have a record here for that, it will answer with this IP. And this is the way it goes back and forth, right? Okay, so let's go further. And this is actually just a detail to see, sorry, to see what resources I've deployed. So you have three VNets, what I've said before. So you have local and hub, the private zones, the forwarders, the demo VMs. One particular point is around the application here. The application that runs here for the demo is simply an Nginx server with a web server, web page running here, right? The default one, actually. I didn't focus on this one. But you see a real application running, a real web page, right? Okay, this is about the DNS forwarder, and you have the zones. So this is already created, and I will create in the demo a record set with www, okay? Let's see the demo. So first of all, I have a bit here. I think I'll change quickly the. You can do that. Thank you very much. Yeah. So you have here, first of all, a set of files for deploying the infrastructure, and you have here a Terraform-based deployment. Maybe how many of you know Terraform here? So Terraform is an option for infrastructure as code. Most in Azure use, actually not most, many use Terraform today. You have IRM, Azure Resource Manager. On the other side, you have Terraform. Especially in multi-cloud environments, you will find Terraform pretty often. And as you see here, you have different resources. So if you use already IRM, you will find the same information, actually, but it's structured differently. And there are also, of course, specific things. So if you see the outline here, you find all the resources I'm talking about. So you have, for example, the VNets. You have the subnets corresponding to that. So just for remembering that the 10.0.10.something is the hub, 10.0.20.something is the application, and 10.0 and 30.something is the hub. Oh, sorry, is the local system. Now I have the VMs that are deployed there, and of course the VMs, they have network cards, and you find these resources here. You have some public IPs, some of them are open, some of them not, and we'll only use a single one, and we'll connect to the client VM, which is exposed on the internet in order to test. And you have the zones, and this is how the zones look like from the Terraform configuration perspective. The first two lines are general, the name and the source group they rely in. The zone type is private, and then you have different other things like registration virtual name, and you have also virtual network ID, and also the resolution virtual network registration and resolution. Okay, and these are collections, and you can add one or more. As of today, you can only have one registration per zone. Okay, in the future, and this will become at the end of the session because I have some fresh news from the product team. We'll be capable to have multiple registrations, multiple VNets being registered with the same zone. Okay. Okay, in the name, actually, you'll find actually the zone name, and this will be actually composed for the name itself is the name of the zone, like in that case DNS 2019.local, so app.something. This is what is composed there. I have a file with variable for all this. I won't enter into detail. And then, of course, we have some protection because we need to have network security groups to protect our networks and so on, but it's not our goal. Good. Now, if we go in Azure, we see these resources here. They are all in the same resource group, okay? And we have what kind of things? We have the DNS servers. I put them in the availability set, and then, of course, I have the VMs here. We have Hub DNS VM0, VM1. We have the app VM and then the local VM, and we have the VNets. The virtual network gateways for the VPN connection. You have a route table also in order to explain that for all the requests going to that central hub, and actually in order to have resolution to the application, we specify that for all the application range, you will go through virtual network gateway, and this is the way actually it knows that for this range it should cross the VPN in order to look for the other address. This is the transitivity part that can be configured, knowing that two virtual peerings are not transitive, important to recall. Okay, and let's go now to the point that is interesting for us. We have, this is one of the zones. And you may see that the things are not so complicated here, and you don't have too many things. These are pretty much general things for an Azure resource, but we have a SOA zone, which is created automatically when you create the zone. And it helps you say that, yeah, you have a zone with this name. It's a record type SOA, and there's a TTL by default, which is 1 hour. And we can change this kind of things, and so on. Okay? And now I will go. So he will add the record set, but we'll do that in a second. If I want to go in my client VM, which is here, I will try to make a request in the browser directly, HTTP, and I will type directly the IP 20.4, the IP of the server where the web application is hosted, and 10.0.24. Yes. So this is the page I have. So the server works correctly, but the point is that I accessed it through the IP. So it's not a good point. I need to have something to use in order to address this. Now, there's something I can test already. Remember what I've told you about app.dns 2019.local. This is the domain, okay, or the subdomain. So if I do that, there's nothing happening, right? And now we'll add a record here for www. Okay? Which will be an A record. I will reduce the TTL to minimum in order to have a practical demo if you want. And I will specify this IP 0.20.4. Okay? So this is it. It's created. And let's go there. And let's write here www.app. And here it is. Okay? So actually, this is the DNS server. Of course, here we can do NS lookup and try these kind of things and see that we have the resolution for www.app.dns2019.local. And yes, it's resolved to this one. Let's try another thing. Let's try, what's the name of the machine there? I think it's app-DNS. I don't remember actually the name, and I'll just take a look. I'll just take a look in my resources. And the VM, it's called app.web-vm, right? And we go there, web-vm, and it's solved also. I don't have any record for that, as you may see. And of course, we type the same thing here. We'll solve the website. Okay. Here's how it works. And there's not too much to say about the solution itself, right? Later, you'll have more features eventually coming, but right now, this is the practical demo. And we'll move forward with some other feedback that we may want to share with you. So, what are the limitations of the service today? You have only one registration virtual network per private zone. So this is something that will be changed. Yeah, let me be practical, yes, because I finished the demo. Thank you. Another limitation is that you can have up to 10 resolution VNets, which is a big limitation. Okay, that means you cannot scale today. This also will be changed very, very soon. I mean, just these slides are the last time that you see them in this form, because simply in 2 weeks, maybe less than that, 10 days maybe, a new version will come out. And there will be a big evolution on that, and we'll have also many of these limitations moving much higher. We can have hundreds of resolution VNets, up to 1,000 actually at this stage, which means that we can totally change our game from the configuration perspective. The reverse DNS works only for private IP space in the registration VNet. Some applications use this reverse resolution, and you have to be aware of that. Okay. There are many, many other things, but let's see something. One thing that happens today is that when you create and you attach a zone to a VNet, the VNet must be empty first time you link it. This is a big limitation for the evolution. This is the feedback we gave to Microsoft, and hopefully they solve these kind of things. I mean, it's nothing difficult for anything that you deploy newly, but for evolutions on the next time when you want to evolve things that already exist, this is blocking, right? Now, another thing is that the record itself is not viewable at this stage from the PowerShell and CLI. This is also be changed in the next days, and you'll see actually the API evolving itself. and it will be much richer. Currently, conditional forwarding is not supported, so, and DNS delegation not supported. That means you have practically a flat DNS model at this time, which can be good enough, but can be limited in maybe in hierarchical structures where you want to simply have a root domain and then subdomains and delegate depending on the where you're on which branch you are on, for example, in the tree. Okay, and today the creation is only via scripts. This will be a new experience in the portal also, very next. And DNSSEC is not supported, so the secure protocol is not supported for DNS today. Okay, so what we saw was that for a full Azure environment, the solution does not need any VM, which is very, very practical. So this is fully passed. But if you want to have a hybrid resolution, this is where our forwarders configuration come in place, and you can avoid it. But you have 2 VMs to manage. So it's a pass-yes combination at the end. Okay. Yes, you can create records via API, which can help you industrialize things. And that means you can build things and construct everything scripted, and this is very, very practical. And you don't have a zone file to manage. For those working with DNS, you know that the zone files are pretty strict, and if you don't respect the syntax, it's something that doesn't work anymore, and all the DNS is. This is much more like structured like a service. It's not a file to manage, which is a good thing. But today the service is not hyper scalable. This will evolve, as I said. And you need this for the VMs in hybrid scenario, and it's flat, as I told you. Okay, and as conclusion for me, there are pros and cons, right? You have a very good time to market with it. So delivering this, provisioning it is fast, configuring a record is fast, deconfiguring is the same. It's easy to do, really. So it's very easy to start something based on this DNS. Simple DNS scenarios are addressed, and also you have these features like the automation name for the name creation for VMs created in the VNet, which liberates you of a lot of work if you have a lot of VMs to deploy there. And on the other side, the service is not completely mature; it's in preview. So just follow and track the changes that may come. And for the hybrid complex scenarios, you may need more investment in your thing. It's not obvious, but as you've seen, it's doable, and it's better in any case than a simple IIS configuration for DNS servers. It's something we prefer largely, and so this is why we stick with the solution, just waiting for it to evolve. We didn't push in production on our side for these reasons, obviously, but we'll probably push in production as soon as the service is mature in GA and stable, and we'll work with it. Okay, do you have any questions?